Hey, well, if you're watching this video, then you must be a Shen Group member. And in this video, we're going to talk about the major equipment we use for our daily research, which is going to be this fluorescence microscope. This instrument contains a few essential components. The first one would be the laser unit here, as well as a bunch of optics that modulate the laser beam for excitation purpose. We have the microscope body, which is where we place samples on, and then also it basically provides a framework so that we can modulate the excitation laser and then also collect emission laser. We have a few little cameras attached to this microscope body. This is a very highly sensitive camera that can achieve the single molecule detection. A consumer grade DSLR camera that's attached to the top of the microscope body. Another available camera port for additional camera. We also have the sample injection pump here. If you want to do the single molecule catalysis, then this pump is also required to continuously supply the reactant into the flow chamber. So we will cover the operation of the laser unit, the microscope body, the pump, as well as this computer software that controls the microscope body in this video. So let's first start with the laser unit. The laser we're currently using is a 532 nanometer continuous laser. The actual laser unit is here. It is mounted here. The laser beams comes out from this little hole here. Okay. However, to turn it on, we actually need to turn on the power supply first, which is located at the lower left corner of this little box. So the very first thing you want to do is to press this button. So this one will get turned on. It has a key here. You'll have to rotate the key to the horizontal place to completely turn on the power supply. Once you turn this key, the laser beam will automatically come out from this laser head. Sometimes this little door here, this metal piece is closed, and in that case you do not see a laser beam coming out from this laser head. All you need to do is to press this metal plate so the laser will come out from the laser head. Okay. So over here, once this laser comes out from this laser unit, we have a continuous neutral density filter wheel. Purpose of having this wheel is to adjust the power of the laser beam that actually reaches out to could reach to the microscope body. So if you rotate this dial, then the amount of the beams comes out, the intensity will change. We use this one to control the amount of laser used for the experiment. And then how we determine the amount of lasers, the amount of laser power we're using right now, we will have to use the power meter, which is located over here. Okay, this power meter has a on and off switch that is on the left side of the unit. All you need to do is press the button once, it will automatically turn on. Okay, the actual sensor is located here on this unit. This is a flipping mirror. The bottom is at the top, this white one. Press it once, then this flipping mirror will be in upright position and redirect laser beam to hit the light sensor, which is this one. Okay, so once it is hitting this light sensor, the readings will directly show up on this meter. And as you rotate this dial, the laser intensity changes. Okay, as you can see from here, it is constantly changing because I am constantly rotating the neutral density filter. Typically for our experiment, we want to set laser power to a value that is between 5 milliwatt to 10 milliwatt. For instance, this time I am adjusting laser power to 6 millipower roughly. Okay, so the unit is milliwatt. 6 is a gray number. We typically use this much of the intensity for a single molecule measurement. Once the laser power is set, what we'll do is to press this button for another time. So the flip mirror will be in down position, and then now the laser light could go all the way and then get into the microscope body. Okay. So for this laser excitation, this neutral density filter wheel is only thing we'll ever touch. Try to avoid touching any of the optics along this line. Those are some of the essential components for the laser alignment. Accidentally bumping to any of the optics will lead to the misalignment of the entire setup, and then this instrument will be under service. We'll have to just adjust them back so that we can continue to do our operation. So handle those optics with extreme care. Again, the only optics we'll be touching when we turn on the laser would be this wheel and then also this flipping mirror. Okay. Nothing else. That's all we're going to be touching. One other thing that is worth noting is that this flipping mirror could also act as the laser shutter that can block the laser light from accessing the microscope body. For instance, if you're in the middle of the experiment and then you do not want your sample to sense any of the laser beam, you can simply just press this button and rotate the flipping mirror in upright position. That way the lasers will get reflected right at this mirror. No beam will actually get into the microscope body. There are actually another access to the flipping mirror, which is at the front of the entire microscope table. Okay. We have a little remote shutter here, which basically acts the same as the little white knob on top of the flipping mirror. So if you touch it from here, it's going to have the same effect. This rotating mirror is going to flip up and then down if you press this button. So that's pretty much all regarding the laser unit. Again, the only thing a student ever need to touch would be the continuous neutral density filter and then also the flipping mirror. Nothing else. We typically set our laser excitation in a mode called the total internal reflection. And then this total internal reflection, if you took my single molecule courses, then you should know what does this mean. We have this excitation geometry set up for this microscope setup. It actually is interchangeable between the TURF mode and then also the epifluorescence mode. In order to switch it between these two different modes, all you need to do is to adjust this knob. Okay, this is an XY translation stage that controls the movement of this lens set, and this is the knob you can adjust. Do not ever touch the knob at the back of this translation stage. This controls the movement along this direction, and it has been carefully measured along this direction. So do not ever touch this knob. Okay, the only knob we'll be using to adjust the TURF versus the epifluorescence mode will be this one. Okay, so essentially for the laser part, we'll just consider the power using the dial, the flipping mirror to measure the power, and lastly this knob on this translation stage to control the angle of incident beam into the microscope body. Okay. Of course, when you are doing experiment, you will be reaching this knob from the front of the microscope. It is a little bit hard to reach, but it's still doable. So you will have to just move your hand over to here, to this position, and carefully adjust this knob from here, from this position. Okay, now laser is on. The next thing we need to do is to turn on the microscope body. The very first thing we need to do is to remove this plastic lens cover from the objective. Okay? Objective is a very delicate piece of equipment. It's very expensive. We do not want to have it damaged by any means. So when it is not in service, the microscope is not in use, we always use this plastic cover to cover this whole thing, so it is protected from dust and moisture from the air. Okay. So before we turn on the microscope body, we must remove this cap. It contains a bunch of buttons to turn on this microscope body. First thing we need to do is to turn this button. Okay, so you can see it indicates step number 1. Means that this is the first thing we need to switch. Okay, once it is on, we'll move to step number 2. Turn this knob. So this one will be on as well. Okay. The reason is because this microscope body, it is fully motorized. A lot of components, they are electronically controlled. Those are the power suppliers to those modules. So we'll have to first turn on these 2 modules, the power supplies to those modules, before we turn on the microscope body. Over here, this is the main console of this entire microscope. A lot of operations would be done